All right, well, welcome everybody to the July 2017 Mississippi PowerShell User Group meeting. Tonight we have Robb Schiefer presenting on test-driven development with Chef, DSC, and Pester. Take it away, Robb.
Awesome, thank you. Yep, so gave this talk originally for the PowerShell Summit this past April. I had given it, I guess, at my company and a few folks, but that was kind of the first big presentation of it, and it was really well received. And so, thanks to Mike for inviting me to come and speak to the Mississippi PowerShell User Group. I've given it to the French PowerShell User Group, and I've got Arizona or the Phoenix one coming up. So hopefully you get a lot out of it, but it's specifically around test-driven development with Chef. And using DSC and Pester in the context of Chef on Windows. So let's just jump right in here. So just a little bit about me. My Twitter handle is Chief7 on Twitter. I'm there pretty frequently. I just received my first Microsoft MVP actually this month. So I'm excited about that. I blog pretty frequently over at .netcatch.com, and I'm the co-founder for the Birmingham.net meetup in Birmingham, Alabama. Professionally, I've worked for 10 years at EBSCO Industries here in Birmingham. We've got somewhere between 500 and 600 developers that work at EBSCO, and I specifically work on an internal business systems team, and we have hundreds of applications and services that we build and maintain. I've been a solution architect for 3 years, and over the last 4 or 5 years, we've really focused on continuous delivery within our group, and probably my proudest achievement has been taking deployments from once a quarter for applications to today we're deploying something to production every 9 hours. So we've put a huge focus on continuous delivery and increasing the velocity of change that we push up through production to our users. So really excited about that, and so part of that is what the talk is today about automation of configuration, infrastructure configuration code. That's what Chef is. So really the problem that it solves is not having to do a bunch of manual server configuration anymore because it's slow, error-prone, inconsistent, and manual. Chef and DSC provide speed, consistency, they make it more repeatable, it's automated, and it's easier to schedule. And so within the context of Chef, though, this talk is really about test-driven development. And we think that's valuable. We know that's valuable because it increases the velocity and produces better designs. So we'll learn about that this evening. So as we go along, feel free to jump in and ask questions if you want over audio, and I'll try to answer those. Or if you're more comfortable, you can just ask a question in the chat session, and then I'll ask Mike or Ron. If y'all see something in there, feel free to stop me and ask those questions for the folks there.
Sure thing.
Thank you. So first, just a quick intro to Chef for those that maybe aren't familiar with it. So it's infrastructure automation via Ruby. They've been around for, I think, since 2007, I think was their founding year. And it was really just a bunch of developers who saw that there was a need for making infrastructure automation easier. And at the time, I think they were using Ruby, or that was the language that they chose then. And so it kind of grew pretty quickly. And they made a lot of headway specifically on Linux to begin with. But the benefits of Chef are that it provides automated, repeatable server configuration. It helps you to avoid configuration drift. It allows you to version your configuration, and it's testable. So there's several main components of Chef that we'll talk about next: the server, the client, cookbooks, and recipes. You can kind of see that visually on the right there. We're going to dig into each one of those sections. So first, the Chef DK. So this is a download that you can get from Chef, and it's basically everything that you're going to need to start to build Chef cookbooks. Cookbooks are the things that the organizational unit for bits of configuration that you want to apply to one or more nodes. That's what they call cookbooks. So they've got this whole language and syntax around Chef and cookbooks and recipes and things. It's cute, but it makes it hard to find things on Google. Oftentimes you get a lot of actual chefs and cooking, so it makes it tough. But so part of the Chef DK, though, what makes it so nice is it's got everything you need to start to build those chef cookbooks, including Ruby and Git. It's got everything embedded into that Chef DK, and they've versioned all of those things together, so you know when you download the Chef DK, they've done all the testing. They know that all of those components work well together. So when you want to get started, obviously Chef DK is the thing that you want to download and install. So just some of the components in Chef DK. There's Food Critic, and that's a static analysis tool. So it looks at the syntax of your cookbooks and your Ruby to make sure everything is kosher there. You have Kitchen. Kitchen is the test execution engine, and we're going to be looking at that this evening. There's Chef Spec, which is more of an integration, a unit testing framework for Chef. There's InSpec, which is more of an integration testing or policy testing framework. And then within your cookbooks, you have a smaller organizational unit, which is called Recipes. So we'll look at all that tonight. Next, we have the Chef Server. And so the Chef Server is where you centralize and manage the cookbooks and the nodes that you have. So you can upload all of the cookbooks that you develop and cookbooks that you can download off the public registry. And you can put those on the Chef Server. It provides a data store where you can have attributes and things about your environments and your nodes. It has search capabilities and reporting. It provides high availability so that you can manage all of that with redundancy and be sure that everything can meet the demand of your infrastructure. It has an API. The supermarket is that public registry of cookbooks that you can download from. There's an official Chef one that's publicly available, but then within Chef Server, you can have a private supermarket as well, so that if you want to share cookbooks within your company, you can do that. The run list is the list of cookbooks that we want to run against a particular node or environment. And then you can have a list of policies as well, which further define how you want things to run in your environment. And then you have all the Chef clients. These are the nodes that we will actually configure as part of using the automation. So there can be many of those, and Chef client is the actual agent that runs on each of those nodes, and it can talk back to the Chef server to figure out what it needs to run. So like I said before, Chef really started out really just on the Linux platform, and they made a lot of headway there. And but then pretty soon after, they saw, hey, there's a lot of Windows servers out there as well. We've got these operations folks that need to manage both Linux and Windows. So they started to add support for Windows, but it kind of came slowly. But around the 2016 timeframe, it really started to ramp up quickly. Chef hired some really great engineers to start working on the Windows side. Specifically, Matt Rock and Steve Murawski made some huge headway in bringing Windows support more closely to parity with Linux. And actually, along that same timeline, PowerShell started working on DSC. And so there's definitely some commonality between functionality available through DSC and then also through Chef. And we'll talk about that today. But what Chef did was they identified that DSC is really more Windows specific, or at least it was initially. And there's this whole community, this PowerShell community that's building DSC resources specifically for Windows. And so if Chef supports DSC, then they can benefit from all of that community involvement, all of those free DSC resources as well. So now you can use DSC resources in the context of Chef, and we're going to look at that. But a lot of people ask, well, if I have PowerShell and DSC, why do I really need Chef? What's the value proposition there? And because Chef's been around a lot longer, they definitely have more features that DSC does not have, specifically around reporting and kind of organization of your automation code and your environments and roles. It has a whole administrative UI and attributes that you can create and store for specific nodes or environments and things. So definitely some extra benefits there that are very valuable on top of DSC. So Chef and DSC work really well together, actually. So let's take a look at a cookbook, just kind of get you acclimated to what that looks like. So I'm in Visual Studio Code. And what I have here is a kind of a typical repo with Chef cookbooks in it. And so you have a cookbooks directory. Within that cookbook directory, I've got several cookbooks. This Acme Win Web is a custom cookbook that I've written, and these others are other cookbooks that I'm depending on that are just freely available from the public marketplace, supermarket. But let's take a look at this custom one that I built. And so basically, there's with the Chef DK, you have a whole console CLI for running chef commands and things. And so you can basically say chef cookbook create, basically. And it creates this folder structure. I haven't really made many changes to it. But this is basically what you get. But the first thing you want to look at is the metadata file. And so it has what you'd expect, some metadata about your cookbook. It has the name of the cookbook and information like the maintainer, the license, a description of the cookbook, the version, which is very important, and then you can list any other cookbooks that this cookbook depends on. So in this case, I'm saying that I depend on PowerShell, and I'm using, this is version 0.10. The next thing we'll look at is the Burks file. So Burke Shelf is a dependency management tool for Chef. So that handles going to the supermarket and pulling down anything that you would need, any cookbooks that you depend on. So by default, you've got the public supermarket as a source. You can add additional private sources here as well. If you set up a private supermarket with a Chef server, you can add that here as well. Or you can extend it to use things like Artifactory or other things as well. But then we have this metadata directive, and that's telling Burke Shelf that, hey, go to my metadata file to see my dependencies. So that's where it's going to go over to metadata file and look and see what do we depend on. In this case, we just have PowerShell. And so you can see down here, I've actually downloaded the PowerShell Cookbook so that we can see what's in there. It looks very similar. You still have a metadata file, you have cookbooks and recipes and things. And then so PowerShell actually depends on these other cookbooks as well, the MS.NET, the Ohio, and the Windows cookbooks as well. So Burke Shelf was the thing that was able to handle all of those dependencies for me. So very, very helpful. Next we'll look at the recipe. So that's you get many recipes within a cookbook, and that's how you would break up and logically organize the different pieces of your cookbook. And so by default, you have a default recipe. And so we'll look at this. This is all in Ruby code, right? So there's a really great blog post on the Chef website about learning just enough Ruby to be able to do Chef. But in general, if you're familiar with other languages, it's really not that hard. You have if statements and loops and things, variables. It's very similar. It's not very tough to learn Ruby itself. So let's see. So here at the top, just the name of the cookbook, the recipe, copyright, blah blah blah. Then we just have a quick debug statement just to say what version of .NET or what version of Windows we're running on. And then I'm creating a variable here if it's not Windows 10. So I'm looking at, this is some code that we can use from Chef that helps us determine what version of Windows we're running. And if it's less than 10, I know it's not Windows 10. And so we'll use that variable later on. Next, I want to include one of the recipes from my dependent cookbook, PowerShell, and I want to run the PowerShell 5 recipe. So the syntax here is the cookbook name, which is PowerShell, and then the recipe name, which is PowerShell 5. And I want to run that if my target node or the node that I'm running on is not Windows 10, because Windows 10 comes with PowerShell 5. Other versions of Windows did not. So I want to make sure that we have PowerShell 5 so I can use DSC and some of the other PowerShell features. Then we get into, again, another variable here for a log folder. I'm just setting up that directory. And here's our first actual resource. So in this case, we're instructing the recipe to create a directory. So it's got an action of create. It's got just a resource name of log folder, and we're setting the path to the log folder variable, which we've defined here, which is just clogs. So we can also, let's skip down here for a minute. So that's an example of a native Chef resource. It's all in Ruby. They've got plenty of these out on the web you can look at for, for Windows. You can create registry entries. You can create files. You can set up services, all kinds of stuff. But then they, like I said, they also support DSC resources within the context of Chef. So in this case, I want to run the file DSC resource. Again, I give the resource a name, and then I set the properties for the destination path and what type of file I want to create. In this case, I actually want to call it create a directory. So that's two different examples of how you would create a directory. First, using the native Chef resource, and then secondly, with using a DSC resource within the context of Chef. So just two different ways to do it. And a lot of times I get the question, well, how do I know which one to use? Should I always use a DSC resource if it's available, or should I only use it if a native Chef resource is not available? And it really just comes down to preference and what makes the most sense. What's easier to read? What's easier to use? So in this case, it's really both. In this case, actually, the Chef resource is only 4 lines, where this one's 5 lines. So it's slightly less verbose to use the Chef resource in that case. But you can imagine there's plenty of instances where a DSC resource can make it much, much easier to create that configuration as opposed to a Chef resource. So let's look for a good example here. Yeah. So in this case, if it's not Windows 10, I want to create a log share in this using this method. If it is Windows 10, I want to use this. Let me uncomment that for a second. I've commented some of this code so that when I run it, I don't have to have an internet connection. It just makes the demo go a little bit smoother. But it all works. You can download it from GitHub and try it yourself. So here, if it's not Windows 10, you don't have some of the commandlets that you have in Windows 10. So for example, if it is Windows 10, we can use the SMB share commandlets in PowerShell. And on top of those commandlets, someone wrote a DSC resource called XSMB share. And then if we want to use that, we've got to download that from the PowerShell gallery. And we would do that using a script here and run install module XSMB share. So this is an example of 2 different ways. In this case, I have to do it this way because if it's not Windows 10, if it's something less than that, I don't have the SMB share commandlet. So I've got to fall back to batch scripting basically to get all that done. Technically, these are PowerShell scripts that I'm doing it, but I'm executing batch commands here. So in this case, the way that you would run just raw native PowerShell is you still use the DSC resource, but the resource type is just a script. And then just like in DSC, you have to give it a set script, a get script, and a test script. And then within here, I'm using PowerShell to run the the net share command. But you can imagine, when you have the capability of using a built-in commandlet, that's much easier to read and understand as opposed to having raw scripts that you have in here like this. So you've got to kind of be pragmatic about it and just look at, what's the easiest thing to use for the given situation. There's plenty of these DSC resources that make very complex configurations much easier on Windows. I think I've seen one for setting up a SQL server, and I think one for setting up an Exchange server. So those kinds of things can be much more difficult if you didn't have a DSC resources. So those are an easy win to use with DSC. All right, so just down here we just have some more resources, and we'll come back and look at these later, but I think that's a pretty good overview of Chef and what it is, and we'll look at some of these other folders as we go along. So any questions before we move on? Anything, general questions about Chef or the cookbooks or any of this code we've looked at so far? All right. All right, so now we want to start to get into the testing aspect of Chef. And so we'll start with the unit testing Chef cookbooks. So Chef, like we saw in the Chef DK, provides the Chef spec tool. and that is a tool for being able to unit test Chef cookbooks. And it's actually built on top of RSpec. RSpec is a Ruby unit testing framework. And so basically Chef has added just helper methods and helper classes and things to make it easier to unit test Chef cookbooks. And one of the big things is they create the sandbox for you to run your unit tests within. So, it wouldn't be a unit test if it actually applied the configuration to a real virtual machine. And so we've got to have a sandbox environment where we can kind of mock out running that, and then we can evaluate how Chef is run against that mock environment or that sandbox environment. And so they call that the Chef spec sandbox. And so what that means is the Chef client is not actually fully run. It's only run within that sandbox, and then Chef spec is evaluating how it runs and then allows us to do unit testing around that. So this is helpful for syntax checking within Ruby and Chef, for verifying logic and recipes. So like those if statements that we saw, or if you have guards, which is a way to only apply resources if some logic is met. We also have expectations that we can set, and then properties on those resources. So, some of these have varying levels of value. But for me, when I started using Chef last fall in the August-September timeframe, and for me, I really struggled with learning Chef. I'm more of a developer historically, working in C# and .NET, and I really struggled to go to Ruby and to get a deep understanding of Chef and how it works, until I saw and found the Chef spec and Kitchen, which we'll look at. And that's really when the light bulb went off. Being able to validate my assumptions through unit tests or through integration tests is really what helped me to get through that learning curve much, much quicker. And so there's a ton of value doing that. And actually what I found was a lot of the tests that I wrote early on, if you were a Chef expert, you probably wouldn't write those. But for me, learning Chef, it was very valuable to write even the simplest of tests that probably don't have any real value other than understanding Chef better and how cookbooks and recipes work. So if you're just getting into this, this is a great way to learn Chef, is to use Chef spec and some of the things that we'll look at. So by default, Chef spec will reevaluate the cookbook for each individual unit test. So it's important to know that. They do that by default because you don't want to share state across unit tests. But there's a downside to that in that you have to rerun that sandbox every time, which can be slow depending on how many tests you have. So there's a way to change that, and we'll look at that. And what's also nice is Shelf also integrates with Chef spec as well. So it handles all of the dependency management there. So that's good. So let's take a look at the unit tests. So over back in our source here, we have a spec folder. And within spec, we have a unit test and recipes folder. And then we have the default spec, which is my unit tests for my Chef cookbook. And so the first thing that we'll have here is we have a reference over to the spec helper. And you can, if we go to that, you can see it's just got some comment and require statements that we would use with all of our unit tests. It's just a way of reducing duplication, keeping your tests dry. So just kind of a helper method there. And then we look in and we actually see some of the tests. So this is an actual individual test. And if you're familiar with Pester, it's kind of similar. They use a similar DSL for defining the tests. But in this case, this is a pretty simple test where we're just saying we expect the Chef run to not raise an error. So that's pretty benign, but a good way to get started. But above that, let's look here. So we have to set up the Chef run variable. And so here we use the let statement to say the Chef run is equal to the work that we want to do in here. And here's where we actually use the Chef spec classes, and specifically the solo runner. This is the thing that sets up the sandbox for the Chef spec unit tests. And so we say we want to run on a Windows platform and a specific version, and then we call converge, which is where we actually execute the cookbook within that sandbox. So we define the chef run, and this is the thing that we're testing. So if you're familiar with test terminologies, this is the system under test, right? This is the thing that we're testing against. Before that, we can set up some mocks, and so this is an example of a mock where you can say allow any instance of some class to receive a method called getSelf, and we expect that to return some text value. So you can do mocking within chef spec as well. And then we get to the top level grouping here, which is the describe and the context, and that's just a way of organizing your unit tests. And so for the describe, we use the cookbook name, which is Acme WinWeb, and the recipe name of default. So this is where we define the cookbook and the recipe that we're testing. And then I'm giving it a further context, which is really just another subgrouping of the tests, where we're saying we want to run on a specific Windows version. And this is a variable, and then right here at the very top, we're creating this loop, and we actually want to run these tests against two different versions of Windows, 2008 R2 and 10. So what this means is it's going to loop through and run all of our tests for both of those Windows versions. It's going to create the chef run with that version number as well, and get us all set up, and then it's going to run all of these unit tests. But let's take a look at another unit test here. So we saw the directory resource earlier. This is the unit test for that directory resource that we saw. So in this case, again, we use the it syntax, and we say it creates a log directory. That's just the name of the test. And within that, we're saying we expect that the chef run will create a directory, and it's going to do that within a resource named log folder, and that resource is going to have a path of C logs. And so this syntax here for create directory, this is what they call a resource matcher. Again, this is part of chef and chef spec, and it's a combination of the action, which comes first. So create is our action, and directory is the resource. So we'll see this further down, but most, really all of the chef resources that are built in native to chef have these resource matchers that you can utilize. And when you need to use them, you just say, you use the action name underscore the resource name, and that's how you verify an expectation on the chef run. So again, that we can compare and contrast here. So let's go back to our cookbook recipe. And so you can see we're using a directory resource. Here's directory. We're using the create action, and we're referencing that here. So it's create directory, and then we give it the resource name, which is log folder. And then we're setting the path to this variable, which is C logs, and you can see we're doing that here as well. And so we'll go over to PowerShell window here, and so you can see I'm in the my custom cookbook folder. And to run the unit tests, we execute some Ruby code. We can execute that within the context of Chef because, like we said, Chef comes with the Chef DK comes with Ruby and everything that you need embedded. So when we need to run some Ruby code, we call chef exec and then whatever Ruby code we need. And so now we're going to run that, and it's going to go through and read our spec files and set up our sandbox, execute our recipe within that sandbox, and then start to run our unit test. So depending on if I have virus scanning happening on my machine, this can take anywhere from a couple of seconds to more than that. So, okay, you can see here now it's actually starting to execute. I've got some warnings at the top around something that's being deprecated, and you really shouldn't use that anymore. We're just going to ignore that. These dots indicate passing tests, and then you can see it's saying it took about 16 seconds to do the full load and run all the tests, but I had 12 examples. RSpec calls the unit test examples, and they all passed. There were no failures. So if we want to see and actually cause a failure, let's just change the name of this directory. So we're only changing it in the unit test. the cookbook and the recipe still have it as C logs. So now those two things don't match. Make sure I saved it. I did. And if we rerun chef spec again, about 16 seconds, we should see a failure where the chef spec has run those unit tests within the context of the sandbox, and it's evaluated how the resource was converged onto the chef sandbox. And you can see this time we had a failure. And here we get some details about that failure. You can see it's this the same test, technically, create logs directory, but it's failing for both of the versions of Windows, because like we said, we're running all of our unit tests against two different versions of Windows. And so you can see here it's laying out that it expected C logs 2, but C logs was actually used. And so this is what a failure within chef spec would look like. And you can see here at the bottom, 12 examples ran, but we had 2 failures. If we go back and undo that change to the unit test and rerun, we'll see that everything should pass normally, as long as I saved, and I did. All right, so we'll come back and see that in a second. We'll look through this a little bit further. So we saw the create directory. Here we've got the create logs share. So we saw that earlier as well. And if it's Windows 10, we expect to use the XSMB share. Again, I have that commented out because that requires an internet connection, and I'm trying to avoid that. And then here, if it's not Windows 10, it's going to run this net share command again. So again, this is just a unit test for all the code that we saw in the recipe here. And so you can see these are the type of tests that probably are not valuable long term, but it helps you gain a faster understanding of chef and how it works. And so that's really more what's valuable here, but it's definitely good to know that. Over time, though, you'll start to learn what tests are valuable and which ones really aren't that valuable, and you'll get to see that. In this case, though, what is valuable, the part of this that is because we've got some logic around running different resources when it's a different version of Windows, that's absolutely something you would want to unit test. And so you can see we're doing that here. But you may not end up validating all the properties on the resource. You may just simply check and see, am I running a script resource or am I running the XSMB share resource? So let's look down here. Okay, so this is a good one. Another good example of the resource matchers like we talked about. So in this case, this is the further resource where we create the data folder using a DSC resource. So in this case, we're going to run a DSC resource named data folder, and it's going to have properties on it, which is what with indicates, where the resource is a file and the properties are the destination path of C data and the type of directory. So again, if we go over, you can see that down here. The resource name is data folder. It's the same as this. We're running a DSC resource. It's a DSC resource. The resource type is a file. Resource type is file, and then we have destination path of C data and a type of directory, destination path C data and type directory. So again, just further examples of different unit tests. The rest of these are actually pretty similar. So let's go back to our unit test run. You can see everything's passing again. Took about 9 seconds that time, and we had 12 unit tests passing successfully. So that's unit testing. Any questions on that before we move ahead? All right. So the next step in our testing journey here is integration tests. So this is where Kitchen comes in, and we talked about how Kitchen is the test execution engine for Chef. And it's a full testing framework, and there's different steps within that framework, and that's what we'll look at here. First is the create step, and that's where, because this is a full integration test, we actually want to create a virtual machine somewhere to run our integration tests against that. And we're actually going to apply the Chef recipe or set of recipes to that VM and then we're going to run our integration test to validate and verify that it did actually execute the things that we expected. So the first step is create, and we can use different drivers, is what they call it in Chef or within Kitchen, to provision a virtual machine of some type. So Vagrant is a very popular one. That's the default one that comes with Chef. But there's really a whole lot of other drivers that you could use to create virtual machines. In this demo, and what I typically use for Windows Chef Cookbook development is Hyper-V, because I've already got it set up on my development machine, and it's just really easy to use. And where Vagrant is a separate install, you've got to have VirtualBox for that. Hyper-V just makes it very easy. Actually, you can use Hyper-V with Vagrant as well, but why that's just one more dependency that we don't need. So we'll look at Hyper-V, but there's also one for OpenStack, which is an on-prem cloud framework or platform. You can use Azure, you can use AWS. There's a whole host of these drivers that you can use. But those are all used to create the virtual machine where we will apply the cookbook and then run our tests. The next step is the actual converge step, and that's where we install Chef on the virtual machine, and then we apply the recipes that we're testing to that VM. We call that the converge step. Next, we have the verify step. That's where we actually run our integration tests. And there's several integration testing frameworks that you can use. Inspect comes with Chef. That was one of the Chef DK tools that we saw, and it's based on Ruby, and so that allows you to validate how configuration has been applied. In our case, we're in Windows, and we love PowerShell and we love DSC, and we have Pester for running integration tests. So we're actually going to use Pester today to perform integration testing against our Chef cookbook. But there's plenty of other test execution or test verifiers that you can use. Server Spec is another Ruby-based one. I'm not sure what all's out there, but I know there are others. And then finally, we can destroy the environment and do all of that again. So let's take a look at our integration tests. So here we have a test folder, and within that we have an integration folder, and then we have a folder with our cookbook and recipe name, and then we have a Pester folder, and then finally the actual integration test, which is a Pester file. So this is a PowerShell Pester file where we've defined the test that we want to run against the virtual machine in the context of Kitchen. So if you're familiar with Pester, it's actually kind of similar to RSpec, where we have a describe block where we say what we're doing here. We're running the default recipe, and then we have the individual integration tests for the different things that we want to test. And again, these usually correlate directly to the resources that we have in our recipe. So again, that very first Chef resource for creating the logs directory, that's this test here. And then we also have the one for creating the data folder, which is what we use the DSC resource to do. And in both of these cases, we're using the test path commandlet to validate that those folders have been created. And then we have some other things here for the file share that we looked at. Again, we have the same constraints in the Windows version that we're using. If it's Windows 10, we can use the XSMB or the SMB share commandlets. If not, we have to fall back to these net share commands that we have to run from the command prompt. And so here again, this is all commented out because I'm trying to avoid an internet connection. But in this case, if it was Windows 10, we could use the get SMB share commandlet to validate all of that, and everything would be great. So that's basically it. So let's actually run the Kitchen verify nano. So that's going to actually run our test, but before we do that, let's go back. So this is the Pester file, this is the integration test that we have, but we also have to configure kitchen with all of the different components that we want to use. So we go to the kitchen.yaml file. This is just the configuration file that they use in Kitchen.
Hey, Rob.
Yes.
We have a question.
Certainly.
So somebody was asking, they said they've seen people run smoke tests from the test kitchen, and they were asking how and why do they do that?
So Kitchen is actually a generic testing framework. You don't have to use it only for Chef. A lot of people, I think I'm starting to see a lot of PowerShell developers that aren't using Chef at all. They can use Kitchen to automate the integration testing of their PowerShell scripts. So at the end of the day, if you need to create a VM, run some code against the VM, and then test it, Kitchen is a great tool for that. So they're probably, in those cases, they're probably running those smoke tests using Kitchen because Kitchen just makes it very easy to automate the provisioning of a virtual machine, the running of some PowerShell code, and then the running of Pester tests against that. All right, so here we can see that this is all the configuration that we talked about in the different steps of Kitchen. So first we have a driver, and I'm using the Hyper-V driver. And then I've got to give it information about how I want to create that virtual machine. So I got to give it the VM switch that I want to use, the VHD folder, the VHD name, username and password, and how much memory I want it to use. And so if we go over to Hyper-V, we can see that it's created 3 different Hyper-V virtual machines for me. I only have one of those running now, but it's got one for Nano, one for Windows Server 2008 R2, and one for Windows Server 2016. And you can see that it's running now. It's been up for about 2 hours. It has 3 gigs of memory, and if we go over to networking, it's got the default internal switch that we defined. So that's where all of this comes from, and that's how Kitchen knows how to create that virtual machine. Next, we have to tell it what transport to use. So because we're testing against Windows, we're going to use WinRM. So there's all of this is provided via Ruby gems. So a Ruby gem is somewhat analogous to like a C# NuGet package. The gem system is just a packaging and dependency management system. And so there's gems out there for we can actually run chef exec gem list kitchen. And so what that'll do is it's going to list all of the Ruby gems that are related to kitchen and have a kitchen in the name. So there's probably 100 or so Ruby gems that are installed by default with the Chef DK. But specifically for kitchen, that we have several here that we're using. We're using Test Kitchen, which is kind of the overall kitchen engine or framework. And then we have Kitchen Pester for running Pester integration tests with Kitchen. We have the Hyper-V provisioner that we're using, and then there's other things that we're not necessarily using but are there if we need them. So that's how you know what all you have, and in some cases you might need to install additional gems to get additional functionality. So you can see we don't have the Azure gem for provisioner for kitchen. So if we say, I think it's gem list, let's say kitchen, and I think the flag is R for remote. Let's see how good I remember that. I maybe. Yep. So now, so you saw before it was looking at local gems here. That's the default behavior. If you give it a -R, that's going to look for remote gems that are publicly available. So here we can see there's an Azure RM provisioner, and there's all kinds of things that you can use. So if you want to use something that's not in the box, you can go out and see what all is available and install these gems to get additional functionality. We got to that because we were looking at WinRM. There's a kitchen. Is it kitchen WinRM or test WinRM? Let's see. Let's say chef exec gem WinRM. List. So, but because we're on Windows, WinRM is what we want to use there. By default, SSH is the one that's used for Linux. But you can see we've got 3 gems here for WinRM, WinRM Elevated, and I don't know what FS is. And so we want to use that. We give it username and password. In this case, this is just a test. This is all a test environment. So there's very little concern about security here. There are you can encrypt secrets and things within the context of Chef if you need to do that, and you can do that within the test as well. But usually I find that's overkill. You don't necessarily need to do that. These are just usernames and passwords that we're going to use with our virtual machine for testing purposes. So next we have the actual provisioner. I'm sorry, I'm mixing terms. So we were talking about, I called it provisioners because it's provisioning a VM. Chef or Kitchen calls those drivers. And then provisioner is the thing that actually executes Chef against your kitchen environment. And so Chef 0 is a local instance of Chef client that you can run. And so that's what we want to use here. That's what's actually going to apply our recipe to the virtual machine. And then we have the verifier that we said we want to use as Pester. That's what the tool, the framework that we're going to use to write and run our integration tests. So that's kind of the raw configuration that you would have. Is just really this bit up here. You've got to provide a driver, you've got to provide the transport, the provisioner, and the verifier. Now, that's great, but obviously we've defined the VHD name as a nano VHD, but we actually want to run against multiple Windows versions. So this is all the default configuration, and then you can override it for different platforms. So you can see I've created 3 different platforms: Nano, Server 2016, and Server 2008 R2. And so for each of those, you can override, I think, all of these settings within the context of each platform. So here I'm specifying the MSI URI. This is for the Chef installer. For Nano, you can't use MSIs. You have to use an AppX package. So that's what we provide here. For Server 2016, we can use the default MSI, which looks like right now, if you don't specify an MSI, it just uses the latest one from the Chef website. So that works fine for Server 2016 and 2008, but for Nano, I've got to give it an AppX instead of an MSI. And then down here, I think the main difference is we give it a different VHD. We give it a 2016 VHD for the 2016 platform, and for 2008 R2, we give it a this is a 2008 R2 VM. What's actually neat is VirtualBox in Vagrant. You can pull boxes off of Vagrant to use in this. You don't actually have to use Vagrant, the tool, but you can use their images basically. So that's actually a good way to go and find images that you need. And I wrote a blog post on that earlier this year. That if you want to do that, you can read up on that. And then finally, we have the suites, which are the integration tests that we want to run. And so the name is the cookbook name and the recipe. And then the run list is the list of recipes that we want to run in this suite. So again, we specify we want to run the default recipe on the WinWeb cookbook. So that's all the configuration for Kitchen. And so to run, well, we just use those commands that we saw. And in this case, I want to run the verify specifically on the Nano platform. So you can, if you don't specify a platform, it'll try to verify all of your platforms. In this case, that would take a lot of time, and for demo purposes, we got to go pretty quick. And so I've only created the Nano virtual machine, and so we're only going to be running against Nano tonight. But the others work fine as well. And so here's the output of the verify command. It's run both of our integration tests, and 2 passed, 0 failed, and ran in about 13 seconds. So that was just the verify step. I had already created the kitchen environment. We can run. Let's see, what time is it? It's 9:25, so we've got about 10 minutes left. I think we have time to do this, so we'll try it. So I'm gonna run kitchen destroy. That's going to destroy all of my virtual machines. And so in a second, we'll see that all these will go away because it's going to delete all of those virtual machines. All right, and they're all gone. So these, I think I had an error earlier where it didn't want to, or didn't create them the right way. So that's fine. We'll delete those manually here. Okay, so no Hyper-V images, but I can run kitchen create nano. And so that's going to go through the create step of kitchen. It's going to read my kitchen file, read any override configurations for this specific platform, and create the virtual machine as it's been configured inside of kitchen. So I think that usually takes about 30 seconds or so. So you can see it created the initial virtual machine. It's starting that up for the first time. And then kitchen's going to try to connect to that via WinRM, which is our transport, and validate that it created successfully. So let's see. You can see some of the CPU usage spiking as it's trying to connect to the virtual machine and validate everything. You can see uptime is only 27 seconds because this is the new one we just created. This point is just validating that it can make a connection and everything's in a good state. There we go. So in this case, it took about 55 seconds. So to create that virtual machine. So the next step, like we saw, was to converge. And we're going to do that against the Nano platform again. And so in this case, the converge, it's going to install the Chef client on the virtual machine if it doesn't already exist, which it doesn't in this case. And then it's going to upload our cookbook to that virtual machine along with all of its dependencies, PowerShell, and all the others. And it's going to run that default recipe and apply all of those configurations that we created via the resources. So it's going to create the logs folder, it's going to create the data folder, it's going to create the SMB share, all of those things. So now that's going to take a few minutes to do that. So while that's happening, we're going to go back and look at how we would use TDD, test-driven development, to actually create something new in this. So the general workflow is you run through the full kitchen verify suite. It creates, it converges, it verifies, and everything's in a good state. And now we want to add some new configuration to our recipe. So let's go through the process of doing that. So what we want to do now is create, let's see, let's go to the integration test first. We want to create a new registry entry. So we can do that within, so we're going to start with the integration test, right? So test-driven development, that means we write our tests first. So in this case, we want to write our integration test first. And so here I'm in my Pester test, and I'm going to create a new Pester test that tries to get an item property from the registry at HKLM software test, and look at the foobar value, and it should be equal to 0. So that's the test we want to run. So over here, it's still installing Chef. So we'll let that keep going. So that's the integration test that we'll run. And as soon as we finish the converge step, I have not saved this integration test yet, and so we'll just undo that. But I want to see everything pass first, and then we're going to add that integration test and see this integration test fail because we haven't actually performed that work yet. So we'll come back to that. But the next thing we would want to do is write our unit tests for that same thing. All right, so in this case, we've got some unit testing here. And so before we ever write the resource within the recipe, we want to write this unit test to basically create the assumption of how we want that to run. So here we create a new unit test called it creates registry key, and we expect the chef run to create a registry key. Remember, this is what they call a resource matcher, and the action is create, and the resource is registry key. So this is going to be a native chef resource that we're using. We're going to target the software, the HKLM software test path, and we want the values. We want the name of the new D word to be foobar. We want the type to be D word, and we want the data to be a 0. And then, so that's how we would do that with using a chef resource. But we could do that with a DSC resource as well. So let's uncomment that. And so this is what our unit test would look like if we were writing a DSC resource for the same thing. So in this case, our action is run, and our resource is a DSC resource. And then we've got the same values. It's all the same. It's just a different way of structuring it using a DSC resource. We have a bunch of properties. The resource type is a registry, so we're using the registry DSC resource. We want to set the properties. We want to set the key to software test. We want to set the value name to foobar, the value data to 0, and the value type to dword. So this is basically 2 different ways of doing the same thing. And these are the unit tests for doing that. Now let's go check on our converge. Okay, so we can see that we had 4 resources successfully converged, and now finally we'll say kitchen verify nano. So at this point I haven't added or saved any of my my registry resource stuff yet. This is all just the default recipe, the default test, all those things. All this should pass. It's running the Pester test now, and we've successfully created the virtual machine. We successfully run the converge step, and we're running the verify now, and we should see that all passes successfully. Yep. All right. So these are all the old tests. Everything worked as we expected. So now we want to actually go through the test-driven development process of adding the registry key. So like we said here, we'll go and add our integration test first. I'm saving that. And so now we're going to run kitchen verify again. And so what we expect to see here is that new test to fail. We want to see the test fail first to know that the test is written properly. If we didn't see that it failed and we only ever saw that it passed, we don't know that it ever went from a failing state to a passing state. So it's always valuable. If you're familiar with test-driven development, they talk about the red-green process. And what that's referring to is you want to see your test fail first, and then you apply the code to make the test pass, and then see that the test passed. That way that you know the test is written well. It will fail when the code that's being tested is not done correctly, and it passes when it is done correctly. All right, so now we can see that did fail as we expected. It was expecting a value of 0, but it was set to nothing, right? So now we know we have a valid integration test. Okay?
Hey,
yes.
We've got a question. When running Pester test in Test Kitchen, can I save test results to other files?
Yes, you can, but the way that Kitchen works and the Pester verifier, it actually copies your Pester test to the virtual machine. So all of the Pester test execution is happening on that virtual machine. So you can write out any results or any files that you want to that, and it will create those on the virtual machine. Separate from that, Kitchen has its own set of logs. So if you go to Kitchen here, we can see the nano and no, I want to go logs, see logs, and look at the nano log. And yeah. So this is the verify run. So if you just need to see the results of your kitchen run, you can go to the kitchen log file. But if you actually want to create results and store those in the context of your Pester test explicitly, that would have to be done in the on the virtual machine that you're testing against. You could have a complex setup where, from that Pester test you were remoting out to some shared server, but then you got to go through all the security and networking complexities of that. You can do it, but that may not be worth it. I'm not sure of the actual use case there. Does that answer the question? Okay, I'll assume it answered the question. Okay, so we saw that this new integration test failed. And so to make that pass, we have to make a change to the recipe to actually apply that configuration change and to create that registry setting. But before we create or before we change the recipe, we need to write the unit tests to validate how we would want to change that. So that's what we did here, and I'll save that now. And I'm just going to keep both of these, and we'll show it both ways. So I've added one test for creating the registry key using the registry chef resource, and then one using the DSC resource. And so now we'll go back and we'll run our chef spec tests. So again, it's going to use chef spec. It's going to create that sandbox. It's going to run our recipe inside the context of that sandbox and validate how it's running, and then check our unit tests against that. So again, we have not actually changed the recipe yet, so we're expecting that this is going to fail this time because we want that red-green process, right? We want to see it. We want to see the test fail first, and then go apply the code to make it pass and see that the test passes. So again, you can see we added 2 unit tests, and each of those unit tests are failing both for 2008 R2 and Windows 10. And so you can see the expected run, that it expected a registry key resource to run, but it couldn't find that resource at all. So that's all failing as we expected. So now we've written the integration test, we've written the unit test, and now we're going to actually go into the recipe and create the registry key here. And so again, I'm going to create it in both ways. So first, we're going to do it with a native chef resource. This is a Windows resource for creating registry changes that's provided by Chef. So again, this is one of the things they added early on to support Windows. And then later, they supported a DSC resources, which is what we're using here. And now we're going to use the registry DSC resource for the same exact key, registry key. We're going to do it both ways. Now, I think there is a bug in this. And I'm trying to remember what it is. The D word 0. Let's just run it. See what happens. That's right. So now I've saved that recipe change, and so all I'm going to do is run my unit tests again. And this time, if I did everything correctly, it should create or it should validate that all of my unit tests pass and that it's running the registry resource and the DSC registry resource, and all of that's working correctly. All right, so I did. I had a failure, so let's see. All right, so this is a problem specifically with the create registry key. So let's go look. So this is a good opportunity to see the Chef documentation site. So we want to look at the Chef registry resource. So they have all, here on the left, you can see all the different resources that they provide. We're looking at the documentation here for the registry resource, and there's a problem with the type. Well, let's see. This is just all about resources, so we've got to find the registry resource. Registry key, here we go. All right, so here we have different types: multi-string, binary, D-word, U-word. All right, I think my problem is I used a D-word and it should have been a string. So let's just try that. All right, so save that on the recipe, and then I want to save that on the unit test as well. I believe this is just an issue with the value type for the registry. All right, so all that saved. Let's rerun this. So you can see here, it's saying that the values don't match. That we were expecting a data of 0 here, but the actual data value was something different. And I think it's registry key types. And I think if I remember correctly, if I set it in a string, it passes. But even if it doesn't, we see that we only had 2 failures this time, not 4. And so this is just a slight bug that we've got to fix. Hopefully this next chef spec will fix it. Yep, I think it did. There we go. So now by changing the type from D-word to string, everything matches out. So I think it's just I don't know if it's a bug in Chef or what. We'd have to work with that a little bit more. But the point is, we wrote the unit test. We saw that the unit test failed, and then we applied the appropriate addition to the recipe, and then saw that those tests passed. So now we know those are valid tests. We know that those resources have been added to the recipe correctly. And so our next step is to run converge, because we actually need to apply those new resources to the virtual machine. And remember, converge is the step where that happens. So this will take a few seconds. It'll run faster this time because it is actually it's already installed Chef client on the virtual machine. It's already applied all the other resources, and so this time it has to double check those things to make sure that's all true. But it really only has to run the 1 or the 2 new resources at the end of the recipe file that we created. But one thing to know is the Chef resources are what they call idempotent. And that means you can rerun a resource many times, and it's only going to apply if it needs to, right? You can rerun it as many times as you want, and it's not going to hurt anything. And so what we'll see is, because we wrote the two resources, one with a Chef resource and one with a DSC resource, it doesn't have to do both. The first one that applies will perform the configuration, and the second one can be skipped. And so you can see, even though we added 2 new resources, only one of those ran, because this is where it applied. And you can see these are the old ones, and these are all up to date, meaning they had already run. We don't have to run those resources again. It found the new registry key, and it actually applied. It created that key, and it set the value. That's what this is here. But then when it got to the new DSC resources, it saw, oh, that registry key already exists, so I don't have to do that again. It's already up to date. So that's why only one of those resources applied. So now we know that registry key was applied, and so finally we can run kitchen verify again against the Nano platform. And so the integration test that we saw previously fail, we should see that passes successfully now. So again, I think it takes about 10 seconds or so to run this. So we should have 3 passing integration tests. And there we go. So now we see that integration test should have registry that was previously failing is now passing, now that we've edited the recipe, we've converged that recipe onto the virtual machine, and rerun our Pester tests, we can see that both our unit tests and our integration tests are passing after seeing that those failed. So that's the test-driven process in the context of Chef. So just a point here, I have the different platforms, and I made mention that we can't run them all because it would just take too long. Obviously, the size of your virtual machine matters a lot. So, for example, a 2008 R2 VHD image is about a 20 gig virtual machine. So it takes about 3 minutes to create that Hyper-V image or that Hyper-V virtual machine. It takes about 5 or 6 minutes to converge it. There's actually 2 steps on this one because it's 2008 R2. We have to install PowerShell 5, which requires a reboot. So that means we have to actually run converge twice. And then the final verify takes about 36 seconds. Overall, it takes 10 minutes total to create, converge, and verify. But once you've done it one time, if you're just adding additional configuration, then it takes about 60 to 90 seconds to rerun the Pester test, the unit test, and the converge and verify. So once you've done it once, it's a lot easier to do it after that. Now, we can compare that to running it against a Nano platform. The Nano image is only 600 meg, so it's much, much faster. It only takes 40 seconds to create the virtual machine. It only takes 4 minutes to converge and 6 seconds to verify. So only 5 minutes total, so about half the time it took for 2008 R2. And then it's about 30-40 seconds in the feedback loop of dev and creating additional things and using test-driven development. So much, much faster there. So the point is, if you have the option, use Server Core instead of full Windows Server, or use Nano instead of Server Core. So use the thing that's most appropriate that you can test the fastest with. So we saw Pester. I think most of the folks here probably know what Pester is, but you can use that with Kitchen. We also mentioned that you can use Kitchen outside of Chef completely and use it to test your PowerShell scripts with Pester and have an automated test framework or test engine or test platform for doing. That's a great option. So we already went through the Kitchen demo. These are just some of the versions that I'm using. So I'm running Windows 10. I think the latest retail release of Windows 10. I'm currently running ChefDK 2026 that just released in the last week sometime, last 7 days. So they're always improving these things. I think they had just released a new version back in April, and I think they had one between then and now. So they're always working on this and trying to make it better, specifically on the Windows side. Matt Rock and Chef in general are pushing hard to definitely get and make more progress there. I'm using Hyper-V, whatever the version is in this version of Windows 10. I'm using PowerShell 5.1, Pester 3.4, DSC 1.1, and then we looked at the Ruby gems and the versions that we're using there. All of the code that I demoed and we went through today is out on GitHub in my personal repo. You can get to it by going to bit.ly/TDD Chef. So you can get to that if you're interested in looking at that further. And then just a few notes on troubleshooting Chef and Kitchen on Windows. A lot of times you'll hit issues with the converge step and you need to get more details. It's helpful to increase the logging verbosity to debug to get more details there. Sometimes you need to look at your gem versions, Ruby gem versions. You might need to update a Ruby gem to get past some bug there. I found that helpful. You've got to be careful too the dependencies that you have. So one of the dependencies I had was on the Windows cookbook. You can see down here. If you don't download those cookbooks locally, it will go out and download the latest version of that cookbook. And so I had an instance where in March, when I was prepping for the PowerShell Summit, the Windows resource changed. Was the Windows resource, the Windows cookbook? I forget. I think it was the resource, which is used by the cookbook, and so that caused where one day it was working, the next day it wasn't because I wasn't using local versions of those cookbooks. So sometimes you got to watch out for that. Other times I've just had weird cases where I have bugs, and if I destroy and then rerun everything, it just works the next time. I don't know why. Sometimes that happens. I've seen some networking issues before. Matt Rock has some good blog posts about that. And then if you need help with Chef on Windows, obviously I'd be happy to help with any questions that you have. You can hit me on Twitter. But in addition to that, Matt Rock is one of the Chef employees that is really targeting Windows, the Windows side of Chef. Steve Morawski is actually a former Chef employee who now works with for Microsoft. Just recently, I think, announced that in the last month. But he's still very active in the community and definitely wants to help. For those are two guys that really helped me, and I'm sure that they'd be happy to help you as well. So that's it. If there's any other questions, we can cover those now. Again, Chief7 is my Twitter handle. I've got a lot of blog posts on Chef and a lot of the things that I demoed here, and a lot of further things if you want to dig deeper into that over on .netcatch.com. And that's it. Hope this was helpful to you. If you have any questions, we can cover those now.
Okay, that was
all right. Well, thank you, Rob. Does anybody have any questions?
Yeah, if you have any questions, just feel free to unmute if you have a mic, or type them in if you don't, and we'll get them answered. Yeah, that was a great presentation, Rob. This is actually the second time I've seen it. I saw it when you did it for your company internally, but I picked up a couple of additional tips during this one.
Good. Glad it was helpful. Yeah, obviously, if you go back and think about something later or have further questions, just hit me up on Twitter. You can download all the source code out on GitHub, but I'll be happy to help if anybody has further questions later. Just let me know.